So I will present that now. Everybody say good morning, Leah. We saw you for a brief second. Oh, there you are. Okay, now we're not going to see you. All right, so sorry about that, Leah. I went through that packet, but you might have been able to scroll through it. Okay, so this is where I'm at. We're going to talk about binomial random variables. Today I'm going to teach you these first two objectives, how to determine if something's binomial or not, and how to compute and interpret probabilities involving binomial calculations. So we talked about this a little bit yesterday. I don't really care if you write this down. I just want your head to be understanding where we are right now. Statistics is all about studying data distributions, and we have all different kinds of data distributions. We have basic data distributions. We have normal distributions. That's what chapter 2 was all about in honor statistics. Chapter 3 was about bivariate data. So this was bivariable data. That's not how you spell variate. V-A-R-I-A-T-E, which means you have X and Y values, and that's called least squares regression. Chapter 4 was about how to do an experiment, and chapter 5 and 6 is what we've been reviewing. It's about probability, and that helps set us up for some special distributions called probability distributions. So back in chapter 1, we learned how to calculate the mean and the standard deviation for basic distributions. The mean, you simply add them all up and divide by how many there are. And the standard distribution, the standard deviation we did the other day on this sheet. With such a sad situation, remember practicing that last week? You take the mean, you subtract how far each point is from the mean, you square it, you add them together, you divide by n minus 1 for some reason, and you take the square root. Then we went to probability distributions. And if it's a probability distribution, there's a quicker way to find the mean, doing the top times the bottom dance. And you can find the standard deviation a different way too. So today, we're saying, okay, now there's even special probability distributions called binomial and geometric. Normal distributions have an n in front with the mean and the standard deviation. Binomial distributions have a unique notation. It's a b out in front with the n and the p. The n is the number of outcomes you want, and the p is the probability of success. What you call a success can fluctuate. You could call a success missing a question, or you could call a success getting a question right. It all depends upon what the prompt is asking you to do. Okay. So we are nested way down here right now. We're in a special distribution called a probability distribution, and we're even in a special place within that called a binomial. So we're like nested 3 deep right now. Just so you have that idea. Okay. Yesterday we started doing this paper with the foreign-born, and we noticed that some things occur in a different order, and we're going to take care of that today. So the first thing we're going to do is, if you can find your purple page that is in a slipcover that looks like this. It was one of the things you got from the back shelf. The other day. And we're going to write on it some, and you are allowed to use this purple paper, and you're allowed to use the one from chapter 5 and 6.1 and 6.2. But this one you have never received until this course. So this one you did not get in honor statistics. So do you have that one with you, Leah? You can just give me a thumbs up if you have that with you. Okay. And I can see you, and Nick can see you a tiny bit, but otherwise nobody else can see you, okay? All right. So the front page of this is all about binomial, and the top is bins. You have to check off 4 different things to see if it's a binomial situation. And your book calls this bins, and I don't have it in the bins order. The first one, number 1, is the B. So you have 2 choices, left, right, true, false, right, wrong, or failure and success. The I is number 3. And if you think too much about these situations, you can start being like, well, yeah, I don't know if that's really independent or not. Just try not to think too deeply and go with the prompt. One big giveaway is the word random. If you have random, then it's almost always independent. Not 100%, but usually. The N is number 2 for fixed number of outcomes. And the S is number 4. Success has to be the same for each trial or each outcome. Notice that the binomial distribution has this notation. That's why in honor statistics, we harped on you putting a capital N with the mean and the standard deviation. All right, we'll come back to this when we get down here to binomial coefficient. And that's going to happen fairly quickly. So don't put this one back in the slipcover yet. And we're going to go to the new packet. I have the coin flip on there, and who knows why I have that plant on here to represent binomial. Does anybody know why I have a plant like that? In biology class, don't you do traits and Punnett squares and things like, are the branches exactly across from each other, or are they like alternating? And you have all kinds of things with how many leaves, and there's all kinds of binomial in biology. So if you're thinking of going into environmental biology or something like that, taking AP Bio and taking this course are almost identical in importance. In fact, I can hardly think of a major where this class is not going to help you in college. Well, I want to be an elementary teacher. Well, guess what you have to take in college? Statistics for teachers. And you might actually test out of it if you do well enough on the AP Stat test. What else? My brother-in-law is a physician's assistant, and he had to take statistics in his physician assistant courses because of chi-square, lots of medicine, lots of statistics in medicine. Anybody else think they have a career that they're not going to need this course? All right. I can usually figure out a way that you're going to see statistics in your future. If you're going to college, you're going to see statistics in at least 2 or 3 of your courses. Like you'll have to take some type of economics class and maybe a psychology or sociology class. If you're going into business, you'll have statistics. If you're going into engineering, you're going to have statistics. Anything in the sciences, obviously, statistics. Computer science, you're going to have statistics. Journalism, you're going to have statistics because there's all kinds of statistics out there in the articles and things that we do. If you're going to be a strict English, and then maybe not. I don't know. Right now, the country is huge into data-driven things and that kind of stuff. So this course is not going to be a waste of your time. All right, so we just talked about bins. So we are going to go through three cases. So if you turn to page 2 for me. We have 3 cases, and we're going to try to determine if these are, in fact, binomial situations or not. Now, I'm reading you through this. If you had this on the AP statistics test, they would not give you 1, 2, 3, 4, but you have to go through all of them, even if the first one fails and you know it's not binomial. They want you to be able to assess all 4 parts. Okay. The seed depot advertises that its new flower seeds have an 85% chance of germinating, which means you stick a seed in the ground and you get a little green sprout. Woohoo! Then it's up to you to water and get enough sun and all that kind of stuff. Suppose that the company's claim is true. Judy gets a packet with 20 randomly selected new flower seeds from the seed depot. Why is it important that the seeds are randomly selected? Well, if they all came from the same flower, like anybody know you can take marigolds and let them dry out and pull off the dead gold petals and there's seeds there that you can plant for the next year? Okay, if they all come from the same flower head, then aren't they all going to be genetically equal? And if there's some flaw in that particular flower head, then they all might have a lower chance of germinating. So that's why it's important that it's random. She plants them in her garden. Let X be the number of seeds that germinate. Amelia, do we have 2 outcomes?
Yes.
And what are those?
Germinate or not germinate?
Mm-hmm. It's not grow or die because a seed's already kind of dried up. So it's germinate or not germinate. All right, so we have the B part of bins. I should have put this in order, so now we're going to the N part. Stephen, do I have a fixed number of outcomes? Yes, how many? How many outcomes do we have? Yeah, 20. All right. Will, are the outcomes independent?
Yes.
Because of what word? Mm-hmm. If that word wasn't there, then you might run into that problem I was talking about of them all coming from the same plant. And is the success rate the same, Val?
No.
Is P the same for all of them?
Yes.
Yes, it's 0.85. Because that's what they told us, and that has to go with, like, you assume that they take all their seeds and they give it a good mix, so you're not getting them all from the same location or whatever. So this is binomial. This will be declared binomial. And once you know that, you can use all the stuff I'm about to teach you today. All right, next example. When an opinion poll calls residential telephone numbers at random, only 20% of the calls reach a live person instead of a person's voice on the answering machine. You watch the random dialing machine make 15 calls. X is the number that reach a live person. Alexa, is this 2 outcomes?
Yes.
Yep, and what are those outcomes?
Reach a live person or not.
Right. Not live person, meaning recorded. All right. Do we have a fixed number of N? Fixed number of outcomes. Joey? Yep, we have 15. So this is true. Are they independent, Alexis?
Yes.
Because of the word? Yep. In other words, they're not calling all the same town at the same time. They're randomly spreading their calls out through the country. And Nick, up front, do we have the same success rate?
Yes.
Yep, and it's 20%. So this would be considered binomial. All right, so gee, I guess what this next one's going to be. All right. Here we go. A student studies binomial distributions using computer-assisted instruction. After the lesson, the computer presents 10 problems. The student solves each problem and enters her answer. The computer gives additional instruction between the problems if the answer is wrong. The count X is the number of problems that the student gets right. All right, Leah, do we have 2 outcomes?
Yeah.
What are those?
Right or wrong?
Or correct or incorrect, whatever you want to say. Do we have a fixed number, Natalie? Yep, we all have 10 questions exactly. Are the trials independent, Mr. Dursick?
No.
Why are they not independent?
Because it's not random.
And because why?
Because sometimes, like, if they're taking a test, the previous problem might affect them.
And what happens if you miss a question? What do they do?
Panic.
Yeah, but it says they do something else. What do they say they do? Yeah, so they provide you with more education if you miss a problem. So they're missing the word random, and if you missed a question, they provide more learning, more instruction. So this is not independent trial, so you could stop right now and say, nope. This is where if they said the problems were randomly selected, it would still be a no on independence because of the additional teaching that occurs. Understood? And then is the probability the same for all trials? Well, it should be 1 out of 5 if you were guessing, which is 0.2. But do you go into all your tests guessing? Hopefully not. So some questions you have more knowledge than the others, right? So this probability is going to vary depending upon how alert you were when you were listening to the instructions. So it's not the same for all trials unless you're just going into it cold turkey and guessing, which I'm hoping that we wouldn't do. So this is not binomial, and it missed the I and the S of bins. We do not have independence between trials, and we don't have the same success rate. All right. Leah, you're going to see this, but you can just like close your eyes for a second. Oh, wait. Never mind. I set this up. I'm trying to set it up so I don't have to fix it between classes. All right. So that's identifying if you have a binomial situation or not. Now we're going to take care of how some things have more than one combination, like we did yesterday with the foreign-born and domestic. If you're choosing 1 domestic and 2 foreign-borns, there are 3 different ways that can happen. If you're doing 1 foreign-born and 2 domestic, there were 3 different ways that can happen. So we are now going to talk about how you figure out how many possible ways something can happen. If there are any boys in here that are colorblind, I apologize. I am a little sensitive to that issue because my husband and son would not be able to tell that we have a green and 3 reds. So if you happen to be somebody who's colorblind, I am not going to ask you to raise your hand because the rest of the day people will be going up to you like my mother used to do to my husband. Do you know what color this is? What color do you think that looks like? How about that? Can you color black? Like she just thought it was a riot to keep asking my husband what color things were whenever she remembered he was colorblind. Okay, so we have 1 green and 3 reds. How many different ways can I arrange those if I wanted to mix them up? Like I could do this. So I know it's at least 2. So how many ways are there total? Anybody want to tell me the answer to that? Yep, there's 4. Because you can move that green one. That's all you can do. There are 4 different orders for that. We call that a combination. You guys have seen this before, I think, if you had pre-calculus. Some notation is written 4, choose 1. We have 4 blocks and 1 green. And some notations are 4 over 1 in parentheses like that. Have you guys ever done problems like this in calculus or in pre-calculus? Binomials, and you expand them using the binomial Pascal's triangle? Well, the coefficients for this, that's what I'm talking about right now. So you've seen one of these notations before, I think, if you did those expanding binomials. Which way did you do it? Is the C's or the parentheses? Did you ever use those? Okay, well, now you know. The AP Stat test does it this way. Our calculators do it this way. Why is there the discrepancy? Because the professors like the parentheses, and the high school teachers like the C's, and whenever that happens, the professors win. Because there's more of them on the AP Stat board than there are high school teachers. All right, so let's do this one. How many different combinations can I do of that? Anybody? Half of us are like, I can't even hold my head up. So we need to have a brain break. After this, we'll do a brain break. And I have new flavors. I have all kinds of candy to choose from, including non-dairy, like Swedish Fish and Starburst. Can you do those? Excellent. Anybody have the answer to this? Thank you, Natalie. Close. So we have red, red, green, green, right? There's one of them. So I could also do what? Green, green, red, red. There's 2. Natalie, what's another one I can do?
You can do red, green, red.
Okay, which means I could do green, red, red. And what's the last 2? Red, green, red. Oh, that's pretty cool. All right, or I could do green, red, green. That would be 4, choose 2, which is 4 over 2, no fraction bar. And there's a formula for that, and we'll talk about that because it's pretty important, but first we need to wake up. So everybody stand up. putting all of these back in the hat so nobody thinks they're exempt for a while. What are your selections? Should you be one of the last four standing? Leah, you are free to go get a drink, pop some popcorn. You got about 3 or 4 minutes, hon. Go ahead and do whatever you want. Swedish fish, which are not in their own little containers yet. Starburst original flavor. Kit Kats. And Reese's Cups. All right. So is it a problem if they touch each other, like the out package? I know, because I know for some people it really is, so that's why I was asking. Okay, so we'll take some of these out. Those are really small, Mrs. Garrett. Okay, you can have 2 Starbursts if you want a Starburst. I didn't buy the fun size, because the fun size is not so much fun. I don't know who came up with that name. I bought the snack size. It's not as big as the regular size. Beggars can't be choosers, just say thank you. And I didn't buy the fun size of Reese's Cups because they're like this big. And you need about 10 of them. The best Reese's product is the what? The eggs. They have the perfect peanut to chocolate ratio. As long as you don't get the white chocolate eggs. Who came up with that idea? All right. Do you want me to do random generating of the colors, or do you want me to do my own in my head? That will be corner 1. That's corner 2. This is 3. That's 4. And I will do it up here so everybody sees. So I will do program. Nope. I'm going to do math. Probability random int. 1, 4, 1. So that's 1, 2, 3, and 4, right? All right. Go, go, go. Pick one. And you can't be in the middle. Like Will is back there in 1. And you guys are up here in 3. Okay, which one's going to be?
3. Oh.
All right, switch around.
It wouldn't do 1 again.
Ready?
Bye.
Go ahead, switch around. 5, 4, 3, 2. All right, it's going to be? No one's there. Switch around. 5, 4, 3, 2, 1. You. Mister, I can't wear it on my nose. Do you need a metal strip? Huh?
I think you need one.
You're good? Everybody ready? 5, 4, 3, 2, 1. We're down. I have to get rid of one more of you before we can select. Ready? 5, 4, 3, 2, 1.
Oh.
All right, ladies. You can have 2 Starbursts or 2 Swedish fish. Do any of you want Swedish fish? Okay, then I'm not going to open it yet.
Thank you.
You can have 2 Starbursts or, yeah, you can have 2 of those, Alexis.
Yeah, I think we should.
Yeah, we are. Go ahead. Get yourself up. I'm going to do 10 of these just to get it warmed up. There we go.
That was a lot of horse.
Holy cow. Humans are really bad at random. We think you can have 3 2s in a row or something, and it happens all the time. Okay. Ready? 5, 4, 3, 2, 1.
Hey.
Sit yourself down. Ready? 5, 4, 3, 2, 1.
I got out.
You got out just in the nick of time. Ready?
No.
James is once again walking to his seat with a big L.
Wilson, you got out in the first round.
We ready? 5, 4, 3, 2, 1.
I don't want to hear it. Oh.
There's 1, 2, 3, 4, 5, 6 of you. Ready? 5, 4, 3, 2, 1. Ready? You guys staying where you're at? Or are you moving? 5, 4, 3, 2, 1. All right, you guys, you three. One more time. You three can pick. Do anybody want me to pick? You can have 2 of those if you take it. Ready? 5, 4, 3, 2, 1. That's you guys. Ready? 5, 4, 3, 2. Oh. Ready? 5, 4, 3, 2, 1. It's gonna be 4 again. I'm feeling it. Go. Ready? 5, 4, 3, 2, 1. Sorry. 5, 4, 3, 2, 1. You guys abandoned ship at the right moment. Ready? 5, 4, 3, 2, 1. Nobody's there.
Oh no.
Ready? 5, 4, 3, 2, 1. Well, that's 5. 5 people. Are you left?
Yeah, I'm out.
1, 2, 3, 4, 5. One more time. 5, 4, 3, 2, 1. Oh! 5, 4, 3, 2, 1.
Oh.
You two. James has made it.
Yes, James, let's go.
I don't know, Stephen, are you going to put your phone away for the rest of the period? Then you can have a participation candy if you didn't get one yet. One more game, really quickly, here we go. It's gonna be fast and furious. Ready? 5, 4, 3, 2, 1. 2.
Oh,
5, 4, 3, 2, 1.
This is the spot.
4. That is the spot. You're right. You're sitting down. 5, 4, 3, 2, 1. 1. Sit down. 5, 4, 3, 2, 1. 2. 5, 4, 3, 2, 1. 4s. 5, 4, 3, 2, 1. 2s. How many are left? 1, 2, 3, 4, 5, 6. Ready?
Oh, come on, Will.
5, 4, 3, 2, 1. You 3. Did you get a participation candy yet, Stephen? If you didn't get a piece of candy after these young winners, they're winners. 2 Starbursts, yeah. But if you're getting a participation candy, it's just 1 Starburst, unless you're Joey, and then he can have 2. All right, if you didn't get a piece of candy, go ahead and take 1. I will put the fish into little. Well, actually, I have gloves that I can use to take the fish. Does anybody want a fish? Anybody want 2 fishes? Okay. Woo!
Am I allowed to get too strict if I already got everything?
No. These are gonna like pop all over the place, so I'll let Will do it. See, not just me being a weakling.
There's scissors.
I do,
He finally
but
does
you have to
it.
cut it because otherwise I contaminate that end. So just don't cut on the, you know what I mean, if you have to cut really tiny sliver.
Oh, I see.
Otherwise you'll cut the zip. Yep. Because once you get it started.
Every 1 to 1.
Yes. Swedish fish used to be my favorite. I don't like the purple ones though. They used to have purple ones back in my day. They had candy cigarettes and candy cigars too that were gum. Way to promote children smoking cigarettes and cigars.
Did you ever pretend that the pretzel sticks or the pretzel rods were cigarettes?
Nope. We had the real candy. The candy cigarettes had powdered sugar in them, so the first time you put it to your mouth, you could go, and it went. Kind of was more like vaping. Little did we know, because it was like a white cloud. But it only was good for one puff. And the end of the candy cigarette was like a dark pink color. So it looked like it was like on fire.
Did you inhale the powdered sugar?
Yeah.
No, some of the candy cigarettes were just these little chalky things, and some of them though were like a little wee tube of gum that was like the size of a straw with a little white paper wrapped around the whole thing. And the end was dark pink, and those are the ones that you could put to your mouth and
Okay. What do they taste like?
gum. The other chalky things tasted like those hearts.
Oh,
Which I hear they have a whole new brand of heart out this year, like
Yeah,
6
it's so
feet
weird.
and not too close and stay away, and instead of like be mine, it's like stay 6 feet away, or like,
stay away. It's like so passive aggressive.
yeah.
Like, but it's not.
But did anybody else hear that they were printing new sweet tarts this year for COVID?
Stay away.
Heard it in the news. It has to be true. All right.
Stay away with the heart on it.
So, something you should know about this combination stuff. Whatever is here, of course, our calculators call it N and R, but not the AP people. College professors one again. It's N and K. So basically, if you have 5 books on the table and you want to choose 3 to read, how many different orders can you do that? Well, you could choose book 1, 2, 3, or you could choose book 1, 2, 4, or you could choose book 1, 2, 5, or you could choose book 2, 3, 4, or 2, 3, 5, or you could choose book 3, 4, 5, or you could choose book 1, 4, 5, or you could choose book 2. It goes on forever, right? Well, there's a formula to do this, and the formula is this. The bottom 2 numbers have to add up to the top, because on your purple paper, so let's go back to that purple paper, and also on page 3, right here is the binomial coefficient. And what I would like you to put in front of that, and that's, I don't know that you can highlight on purple paper. I would like you to put on front of this NCK. Now that formula really is on your green paper for the day you take the AP Stat test. But that formula is a pain in the butt, and it's much easier to do it the way I'm going to explain to you. But before we go there, I would like to tell you about the pieces parts of this formula. So the first part is telling you, that's just notation. The next part is telling you how many combinations you have. Like in the foreign born, we had 3. So you can be writing this on your purple paper that you had out of the slipcover. Well, most of us had it out of the slipcover. Mr. Kale didn't. Oh, he does now. That's good. Do you have the top stuff written on the purple paper? See, oh, you do, sort of. Yeah, you do. My bad, I apologize. Making fun of Stephen, and I shouldn't be. All right, what's the P? The P is your success probability. And these K's should always match up. That K is in 3 different spots. And then you have 1 minus P, which I call the failure rate, and your college books will call that Q. But we call it 1 minus P. So that's your fail rate, which is just 1 minus your success rate. And then the coefficient that's over here, which is n minus k, you just have to make sure that these two add up to n. And we're going to do enough that this will all make perfect sense here momentarily. All righty. So let's turn to page 3. And at the top, you have that formula. And if you need to move over a little bit that way, you're certainly welcome to do so. On the top of page 3, you have this. And if you put this 8.3 into that formula, this is all the work you have to do. I personally like to think of it from here, and I like to go right here. Because whenever I see 8 choose 3, this is what I think of. Oh, by the way, do we all know what a factorial symbol does? Have you seen that before in your mathematical career? Like 6 factorial means 6 times 5 times 4 times 3 times 2 times 1. So 100 factorial would mean 100 times 99 and 98, 97, 96, 95, 94, 93, 92, 91, 90, 89, all the way down to 1. Don't go all the way down to 0, because if you go all the way down to 0, you would have 0. So this is what I think of when I see 8 choose 3, which is also 8 over 3, no division bar. You must have a parentheses. I think to myself, take 8 out 3 places. So I'm going to do 8 times 7 times 6. Only do 3 places of the factorial. And then divide it by the second number, 3, 2, 1. That gets me right here without having to think about through the formula. And then I kind of like this because you get to simplify and feel really smart. 3 times 2 is 6, so that divides out the 6 from above. And I'm just left with 8 times 7 over 1, which is 56. And those of you that know what is coming, just save it for a minute because I'm going to show everybody that too. I kind of like you to understand the little algebra behind this. So for the 5 choose 12, or 12 choose 5, the top number always has to be bigger than the bottom. I'm not going to think this way. I'm going to think, take 12 out 5 places, and divide by 5 factorial. Or factorial, some people pronounce it factorial. And now I start slashing things. I know that 4 times 3 is 12, so I can take the 12 out. 4 and 3. And 5 times 2 is 10, so I can take the 10 out. So now I'm left with 11 times 72, which is 729, I think. Did anybody do that yet? I don't know if I'm remembering correctly from block 1 or not. 11 times 72. Yep, 790. Oops, it's 792. I was close. All right, who doesn't have their graphing calculator with them? You have to give your candy back.
It's charging.
All right, anybody else not have a calculator? I have one. I have one to spare because I gave up one of them. Apparently, Philip doesn't have a new calculator. Did he lose his new one years ago or something? He has like an old 83. He doesn't have an 84.
I can.
You're not in charge. I understand. So Philip now has my other classroom calculator that he better not lose, or I'll have to take him out. Meet him in a dark alley after the school year's over. All right, this can be done in your calculator as well. Ready? Of course, it has the R instead of the K, but here's how you get to it. You go to math. To get to probability, it's quicker if you just left arrow. And then do you see it in number 3? The problem is you have to have the first number in first. So to do 8, choose 3, I would have to put in the 8, math, probability, go down to number 3 and put the 3 in and then hit enter and it gives me the 56. So go ahead and practice that with the 12, the 15, and the 45 and 18 and see what you get as your answers. There's all kinds of little shortcuts I'm going to give you today, but I have to give them to you slowly because I want you to still understand what's going on, not just to be a pattern learner. We all know what happens to pattern learners when you get to calculus. The paddle comes out and you just feel like, did I learn anything ever? Like, oh my God, calculus, it's hard. I have to remember everything everybody ever taught me mathematically. Yep, that's why it's called calculus. No, it's called calculus because I think it has something to do with Pascal. He's the father of calculus, isn't he?
Didn't you make it up?
Yeah. He was a big scientist and he needed to make areas infinitesimally small, so he came up with calculus. Archimedes was this close to calculus. This close. But there was something in Archimedes' toolbox that was missing, or he would have nailed it. Archimedes would be the father of calculus if it weren't for this sad fact. In Archimedes' day, they didn't believe in the concept of infinity. Mathematicians way back in the day used to not believe in like negative numbers. That kind of rocked the world. And then fractions, oh my gosh, that rocked the world. And then decimals, whoo! And then the concept of infinity totally caved in some people's worlds. So I'm sure there's some things that we don't know about yet that will rock our world one day. Yeah, like how a pandemic spreads. There you go. I mean, if you really think about it, it is hard to believe that in 1 week's time, we went from that to this. And then all spring, we didn't have to be home, but we didn't know any better. We could have been here like this. I would have been scared to death because I was really afraid coming back here that I'd give it to my dad. But Chris and I are coming from 2 different schools, and so far we haven't given it to each other or to my father, so that's good. I will feel, I'm not even gonna say it because why jinx myself? He already has his first shot. If we can get through the second shot, there's still a slight probability there, but I will feel much, much better about a lot of things. All right, so what'd you get for the next one? 15 choose 10. I would like, oh, look at that. I randomly chose that. What'd you get, Stephen, for 15 choose 10? 3003. Yep. Yepers. 3003. And very quickly, your calculator would not be able to have enough memory to handle this because 5 choose 18 is what, Amelia?
I'm not really sure.
Times 10 to the what?
12.
So that's in the billions somewhere. Okay? So you can calculate the coefficients, which means the numbers in front, using your calculator. So now let's get to this binomial thing on page 4. We're going to use this formula that we just talked about. And we are going to, there's the formula right there. Tomorrow we'll do this stuff, how we got to that. We are going to do it right on this page. Okay. So the notation is binomial. I have 10, and the success rate is 0.27. The chance of me picking somebody who is not born in the United States, if they live in California, is 27%. You must have this notation down regardless of the way you choose to get the answer, because there's about 5 different ways you can get the answer. You can do it the long way. You can do it a semi-long way in your calculator. You can do it with a pre-programmed command in your calculator, or you can do it with a program that I give you, and I'll show you all of that so you understand. But regardless of what you choose to use, you have to have this notation. The probability that x equals exactly 3 is, so here's your first choice that you're allowed to have. You can use the C notation or you can use the parentheses notation. I'm going to use parentheses because that's what you'll see on your AP Stat test. 10 choose 3, which means 10 times 9 times 8 over 3 times 2 times 1. And that means that would be, let me think, I can do this in my head. 10 times 9 times 8, well, that becomes a 4, and that becomes a 3, 120. There's 120 different ways for me to have 10 pieces of candy on my table, and you come up and pick exactly 3 of them. I could pick the Reese cup, and then the Swedish fish, and then these pink starbursts, or whatever, what are they called? Starburst. Or I could take the orange starburst, and then the Kit Kat, and then the Reese cup. There's 120 ways to do that. Somebody can check me on that, but I'm pretty sure it's right. Is 10 choose 3 120? How'd you do that so fast? Well, look, see, I went like this, and I said that becomes a 4, that becomes a 3, that's 12 times 10 is 120. That's how I did that. I don't encourage you to do that way. Okay. I have 27 to the bottom. That 3 comes here. That's how many I want. And then I do the subtraction in my head. 1 minus 0.27 is 0.73. That's called my fail rate. If success is being a foreigner, then being domestic is considered failing right now for this problem. So I'm going to put in 0.73. I highly encourage you doing the -1 thing, even if you have to use your calculator. I encourage you to do that first. And then I say to myself, so 3 plus what gets me to 10? 7. Okay, so you could work that all out in pieces parts. You could do this and get 120, then you could put that into your calculator and get that number, and then you could put that into your calculator and get that number, and then you could multiply all 3 of them. Not my favorite choice. So let's just do this in our calculator. 10, math, prob, choose 3, parentheses, 0.27 to the third, parentheses, 0.73 to the seventh. Enter. Keep at least 4 decimal places unless it's a bunch of zeros, and then keep everything until you get to a number that is, what do they call that? A significant figure? So this is what? 0.2609. There are 2 better ways to do this, but I really want you to practice this way on the next 3 problems. So I would like you to do 2, 3, and 4, but don't go to 5 yet, please. So please do problem 2, 3, and 4 on this page. Writing the notation just like that, except for you're changing a few things. And using the calculator. So practice that, and then I will give you the gifts. And you'll be happy, happy, happy. Just like the father from Duck Dynasty. Didn't know, he always say people would be happy, happy, happy? Anybody ever watched Duck Dynasty? I think it's considered politically incorrect now, so. Apparently one of my favorite country music singers spewed some incorrect things when he was drunk, and now he's in trouble. Morgan Wallen. That's because all of that is down in the 3 spot instead of being upstairs. Yeah, those calculators do that. Does anybody know who Morgan Wallen is? He sings line 'em up, line 'em up, line 'em up. And he also sings, one of my favorite songs is I Can't Love You More Than My Hometown. I really like that song. And I don't know what he spewed. I haven't Googled it yet. I'm thinking that's what he did. Oh, you know that he said that? Because they kept saying a word, and I couldn't think of any other word other than that, and I'm thinking Morgan, Morgan, Morgan. I like Sam Hunt too, but he gets himself picked up for drunk driving too much, so I don't know. Sadly, sometimes when people are inebriated and out of their own self-control, they show their true thoughts, and that's not good. Just like that, one of my favorite actors is like that. Mel Gibson, he's pretty inappropriate when it comes to certain mindsets. Kind of amazing I made it out of my house without being pretty racist and prejudiced against sometimes. My mom, God bless her. Whew. The older you get, the less you have control over your filters. The things she said in front of my children, oh my goodness. I should have washed her mouth out with soap. Did you guys ever get your mouth washed out with soap? I did once. It was not pretty. Said the F word in front of my dad. That was a mistake. Granted, I had a gerbil hanging from my nose because he had just bit my nose because we were trying to find him. He got out and he was running around the house and I found him and I picked him up and I said, "You've been bad." And he went, "Arr!" And then he's like, "I'm like, he's on my nose. Get him, look. What the is he doing on my nose?" Suddenly the gerbil was unimportant. What did you just say, Pamela? I said the gerbil's on my nose? No, that's not what you said. I'm like, but he's still on my nose and it really hurts. I don't care about the gerbil right now. I'm like, oh. I'm sorry. Yes, you are going to be very sorry.
I got mine washed off, thank God.
Oh. My mom's swear word of choice, when you knew she was completely ticked off and pissed off at you, and it almost made it worse because it was so funny. My sisters and I could hardly stand it. We'd start laughing. She'd be like, "Oh, Pamela, hell's bells. Now look what you made me say." I'm like, "Yeah, hell's bells. That's pretty bad, Mom. I'm pretty sure you're going there for saying that. It's not funny, young lady." Well, it kind of is, Mom. That was her big swear word. Hell's bells. Whew. What does my dad say when he gets mad? He just slams doors a lot when he gets mad. I've never heard either of my parents say the F word. Well, my mom can't say it now because she's up in heaven and they won't let you say it there. But my dad's 93 and I've never heard him say the F word or the S word. Somebody, who was I sitting in the cohort with last week on Thursday? Katie Haynes was sitting with her. She could not stop saying the F word. That's the only adjective she had in her vocabulary. That was effing, and boy, that cake was, instead of saying really delicious, that was effing good, and this was effing this and effing that. I was like, oh my God, stop. Pick a new word. You sound silly. I don't know. I don't quite get it. Yes.
I just remembered that I saw a really funny pie chart yesterday that I thought you would think.
Does it have the F word in it?
No.
Okay.
Here.
Send it to me. You'll get a point.
Oh, okay. I'll use it.
Email before somebody else does. Okay, ready? Everybody's had time? Alexa, what did you get for the second one, my dear? Wait till I find the answers. Okay, let me, okay, what'd you get? Just give me the 4-digit answer.
0.2646.
Yep, and everybody should have that probability. This is exactly what I'm looking for on your homework tomorrow. All right, Val, what'd you get for 1?
I had 0.15895 because I didn't know how you wanted to round it.
Yep. And somewhere, I don't know where, it scares me. So say that again, 0.15895.
Mm-hmm.
And let's say there's a 7 here. Somebody said, well, you start at the end and you just keep rounding up. Like, what are you talking about? No. If I want to go to position 4, I just look at the 5. I don't look at the 7. Like if this were a 0.15894, then I'd leave it alone, right? I know the 7's there telling the 4 to become a 5, but you don't do that before you, you guys understand that, right? Like somebody once was like, oh, you start all the way back here and you just keep round and round. No. All right, so that's really a 5. So I don't care about the 7. I really don't care about the 7. 7 has nothing to do with it if I'm rounding to 4 places. The 5 tells the 9 to become a 10, which makes the 8 become a 9. Right? You guys are good with that? 1590? All right, Mr. Bullrat. What about 0?
0.0429.
Yep. 0.0429 what?
7.
Okay. So 0.04297. The 7 tells the 9 to become a 10, which tells the 2 to become a 3, so it's 0.043. And that one you could have done almost in your head, or you could have just punched in 0.73 to the 10th power, because here's a bit on the notation. Anything to the 0 power, or anything choose 0 is 1. If I have 3 coffee cups on my desk, how can I walk up to 3 coffee cups and not choose any of them? One way, I just walk away. Also, if this number matches the bottom number, that also equals 1, because that's the end of Pascal's triangle, for those of you who have had that. If I walk up to 3 coffee cups and I want to choose 3 of them, there's only one way to do it. I pick them all up and I walk away. All right. Now, if whatever number's there, if there's a 1 here, that equals that number. So 10 choose 1 is 10, because if there's 10 things sitting there, how many ways can you choose one of them? Well, I can choose the first one, or I can choose the second, or the third, or the fourth, or the fifth, right? And that also happens to be the same if you have some number up here and you have the number 1 as 1 down below. So 10 choose 9 is also 10. Just for those of you that want a little bit more algebra knowledge. All right. Before I show you the fun, easier, helpful ways to do things, let's look at number 5 and number 6. Number 5 and number 6 are really why we need these other ways. Because the number 5 says at most 3. At most 3. To be honest, some of us are really bad at least and greater than, or equal to, and less than or equal to. Some of us are bad at most. Some of us are bad at more than. If you're one of those people, then put the numbers out there. At most 3 means I want, is 0 good? Is 1 good? Is 2 good? Is 3 good? All right, so it means I want 3 and below. Well, I could just add up 1, 2, 3, 4, get the answer. Or you can use a fun little thing in your calculator. So here we go. Ready? In your calculator, there is a thing called binomial PDF and binomial CDF. PDF gives you 1 at a time. CDF gives you from the number you put in down to 0. So if you do second bars, and bars is right by the clear button. You can't see it on that screen yet, right? It's all the way down at the bottom. So those of you with the fancy new color screens probably can see it. On my calculator, it's A, binomial PDF, and the next thing I do is really important. When you press enter, do you get that prompt? Is there somebody who does not get that prompt screen because you have an old operating system and I need to update you really quick for a lot of things? So did everybody get that screen? You didn't?
No, I just had a question. What do you get after second bars?
You go down till you see binomial PDF, which is all the way down at A, I think. So let's do number 1 again. I have 10 trials. Probability of success is 0.27. The value of X is 3. I want exactly 3 foreign-born. Hit enter, and we get the 0.27 again, or the 0.2609. That's number 2. Nope, that's number 1, right? So you mean you taught us how to put all that in by hand, but we really could have done just this? Yes. Why'd you do that? Because you never know what they're going to come up with on the AP test. You might have to do a pieces parts of something. And you can't do the pieces parts if you just use this. All right. So the answer to this one is actually second bars go down to binomial CDF. And that's going to add number 1 plus number 2 plus number 3 plus number 4. It adds all 4 of those decimals together. You put in the same thing. 10.27. I want to go from 3 down to 0. And I know I'm doing that because it says CDF and the C stands for cumulative, where the P stands for just regular one-old probability. So go ahead and hit enter. Paste enter. And that gives you 0.72 something. And if you add up those 1 through 4, that's exactly what you get. So what's the notation you want us to write, Mrs. Garrett? Well, I'm glad you asked. This is what I want you to write for the notation. The probability that x is less than or equal to 3, because that's what at most means, is 10 choose 3 with a success rate of 2.7, which means the failure rate is 7.3. Oh, why'd you put a 2 in there? I have no utter, I don't know. Got nothing for you. I don't know why I put a 2 there. Plus dot, 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 all the way down to 10 choose nothing. That's the notation you should put, and the answer is 0.27 what? Repeat 0.7274. That's what I want to see. But the reason for the final gift that I'm going to give you before you leave today is because this next one wants you to go the other way. It wants you to go at least 3, which means 3, 4, 5, 6, 7, 8, 9, 10. Well, that's pretty easy, Mrs. Garrett. Can't you just take from 1 and subtract 2 and down? Yeah. But sometimes they ask you for a middle bunch, like from 3 to 8. Well, can't you just do 8 down and subtract 2 down? Yeah, but some of us can't think that fast. And some of us get really confused. And so there is a legal, AP Stat legal program that I have gifted you. Did we ungroup the group last week? Okay, so ready? I think I might have to give this to you, Rourke. Hit second plus sign. Says memory. Go all the way down to group, which you can get there quickest by going up arrow. So go to group, hit enter. Go to ungroup, and hopefully you have AP Stat right there. And then you should just hit 3. I'm going to omit these because they're, there we go, overwrite, omit. You get like 5 or 6 programs, right? Hang on, I'll help you. Let me show this, and then I'll help people. Watch how nice the program Binoprob is. It does everything. Probability of success is 0.27. The number of trials is 10. I want to go from 3 to 10. There you go. That's the answer to the last question, number 6. Now, what if you want to do exactly 2? Guess what you do for this program? Program Binoprob. Probability of success is 0.27. Number of trials is 10. I want exactly 2. Guess what I put in for the low and the upper bound? 2, 2. It's the same. And it will give me what you guys got for question number 2. So it doesn't matter which way you do it. You don't have to be fantastic at all these methods yet, because I don't expect you to, and that's what the notation should be for this last problem, number 10, number 6. But that is a tool that you will come to love. It's just sometimes you can't use it. Your homework is page 5 and page 6. You cannot do number 6 on page 5 yet. I have to teach you that tomorrow. So number 6, the mean and the standard deviation, well, you probably can do it. It's not hard, but you have to write down this notation, though, on page 5 and 6. You can't just have the answer. Yeah, you can skip number 6. All right, have a good day. Brooke, do you have that in your calculator?
Yeah, just,
Because I can give it to, I can give you the whole AP stat. And you, yeah, now you have program environmental. All of the your guys do. Program. And let's see if you have a group of something happens to the program. Yep. Okay, so I will send it to you. Yep. You said you're sending that to Leah? Yeah. You can tell her that she doesn't have to feel like she has to print those out, and I don't know if, do you happen to live close to her?
No, but I can go.
Like, you could just, like, if you want to, you can ring the doorbell and run or something. No, she doesn't know yet, but yeah, I mean, that, and she doesn't have, if you can't get to her today, tell her she doesn't have to print it. I already told her in an email, but she can just write down the answers on paper. All right, so Hannah, you're still here, right? And you're going to art class. Guess what? I remembered. Okay, I'm sending you that group. See, Luke? Luke, Will, it's almost over.
yes, halfway there.
Yep. See? And we're gonna overwrite all. What is it? That's weird. I don't know. No, it looked like you were in the right place. Group and group. That did not look like that 3 seconds ago. It wasn't you.
How do I get?
Program. Hit program,
Oh, and you just have it now?
and now you can go to buy no problem and put the stuff in.
Oh, okay.
And three. Okay? All right, and I will give you a pass to art class. All right. I need to go get some passes because I have to keep using my homework excuse sheets. Which is okay. I don't mind. Oh, I'm tired. This week it is Wednesday, which is nice.
I might need a pass too.
And where are you heading?
And
Okay. What time is it?
10:42.
I wanted to ask about the butter.
Yes. So I will rip that off for you. There you go. Yep.
So I finally got a date for the Kenson Foundation scholarships. So
Okay.
the March 5th. And then there's one scholarship that I need to submit the proclamation for.
Okay.
But other than that, I can just put it all a big stack.
Okay, so there's nothing I have to upload to any place for?
There's one that I can send you the email request to.
Okay, when's that due?
June.
Oh, well,
Yeah.
I want to, like, your letter is halfway done. It's going to be in your hand by Friday for sure.
Okay.
Like, I'm going to work on it right now, this block. I have one other one that I have to work on too. Well, I've already written it, but I have to chop it apart.
Okay.
And I'm getting in trouble because I don't have my sub packet in yet. I never have my sub packet in. I'm like, I'm not absent. You'll get it before I'm absent. Just take a deep breath. But it's the COVID and you never know. And I'm like, okay. I'll get it in. So what time is it? 10. I'm gonna put 10:50.
It's 10:44.
So that gives you time in case you have to go to your locker. All right. Yep. Have a good day.
Thank you.